There are stellar systems where diamonds rain down and others where stars consume their planets. This audiobook accompanies you for 2 hours on a relaxing journey through the most astonishing data of the universe. From suns burning at impossible temperatures to worlds that defy the laws of physics, each story is a window into the unknown. While your body rests, your mind explores, and every piece of data, every cosmic image, ignites wonder. Human curiosity has been the driving force behind our quest to understand the cosmos. Since time immemorial, we have looked to the sky, wondering what lies beyond our home on Earth. Are we alone in the universe? Do other worlds exist that could harbor life? Each time we gaze at the stars, we face a myriad of unknowns. With every discovery, we get a little closer to answering these questions, and today we will focus on some of the systems closest to us. At the heart of our exploration lies Proxima Centauri, the closest star to our Sun. Imagine you are in a desert surrounded by sand and solitude, and suddenly an oasis appears in the distance. That's how it feels to discover Proxima Centauri in the vast desert of space. At a distance of just 4 light-years, this star is a beacon inviting us to explore its secrets. But what makes Proxima Centauri so special? Red dwarf stars like Proxima Centauri are the most common in our galaxy. The Milky Way. Think of them as the small but powerful lights at a grand party. Although they are less bright than many of their larger companions, their abundance and longevity make them the protagonists of stellar history. What secrets do these stars, which seem so humble at first glance, hold? The answer to that question could change our understanding of life in the universe. Delving into the Proxima Centauri planetary system, we find 3 planets orbiting this star. Imagine a cosmic dance, each planet moving in its own orbit like dancers on a stellar stage. One of them, Proxima b, lies in the habitable zone where conditions might be suitable for life. What kind of worlds could these be? Do oceans, mountains, or even creatures inhabit their surfaces? Looking towards the Alpha Centauri system, we encounter a stellar group that shares a similar fate. Alpha Centauri is a system that, like a cluster of bright lights, consists of 3 stars. Alpha Centauri A and B are the most prominent, and together they form a duo that we could compare to a pair of bright twins in the sky. But what differentiates them, and what do they reveal about the formation of stellar systems? Alpha Centauri A and B are fascinating due to their mass and luminosity. The first is slightly larger than our Sun, while the second is a bit smaller. This duality leads us to wonder, how does this affect the planets that might orbit them? The possibility of life on these planets intrigues us. Could conditions similar to those we have here on Earth exist? Continuing our journey, we find another nearby system, Barnard's Star. This system, although not as well known as the previous ones, is a hidden gem in the vast cosmos, known as one of the closest stars to our solar system. Barnard is like a wise old man who has been observing the universe for millennia, but what can it tell us about the planets that might orbit it? In the Barnard system, we discover an exoplanet called Barnard B. This planet, which lies in the habitable zone, raises more questions than answers. Is it an icy world, a barren desert, or could there be life on its cold plains? Each discovery in this system brings us one step closer to understanding our place in the cosmos. Lumen 16, a system of brown dwarfs, adds another layer of mystery to our exploration. These stars are not really stars in the traditional sense, but rather bodies that lie between stars and planets. Curiosity is sparked as we ask, what kind of worlds could orbit them? Could there be planets in these systems that challenge our current understanding of what a planet is? Wolf 359, on the other hand, is one of the faintest stars we can observe from Earth. Its dim light is like a whisper in the vast silence of space. But what secrets does its system hold? Could there be planets that, despite their proximity, are completely unknown to us? Finally, we explore Gliese 411, another red dwarf that offers us a new perspective on the formation of planetary systems. Each of these stellar systems we have mentioned is like an open book. full of stories waiting to be told. The search for life, the study of their characteristics, and the understanding of their evolution are just the beginning of an adventure that will take us through the immensity of the cosmos. So, as we embark on this journey, let us remember that each star, each planet, and each system is a piece of a gigantic puzzle. As we unravel these mysteries, we get a little closer to understanding not only the universe but also ourselves. What else does the exploration of these stellar systems hold in store for us? The answer to that question is waiting to be discovered. Proxima Centauri, the closest neighbor to our Sun, is like a small beacon in the vast darkness of space. But what makes it so special? First of all, Proxima Centauri is a red dwarf, a star that, despite its modest brightness, plays a crucial role in the study of astrobiology and the search for life beyond Earth. Its proximity, just 4 light-years away, makes it an ideal target for astronomers who wish to explore the potential of other habitable worlds. The Proxima Centauri system consists of this star and 2 other stellar systems, Alpha Centauri A and B, which orbit each other. But did you know that red dwarfs are the most common stars in our galaxy? They represent about 75% of all stars in the Milky Way. Despite being smaller and cooler than our Sun, these stars have an incredibly long lifespan. Some can shine for trillions of years. This raises an intriguing question. What kinds of worlds might exist around these ancient and stable stars? Proxima Centauri has a surface temperature of only 1300 degrees Celsius, making it much cooler than our Sun. However, the planets that orbit close to it could be in a habitable zone where conditions are suitable for liquid water. This possibility is not trivial. In fact, at least 3 planets have been discovered around Proxima Centauri, and one of them, called Proxima b, is in the habitable zone. Could this planet be home to extraterrestrial life? Visualize Proxima b as a world in a delicate dance. It is at a distance that allows it to receive enough light from its star, but not so much that its surface becomes a scorching desert. This means that if it has a suitable atmosphere, it could harbor oceans of water and therefore potentially life. But what else do we know about this fascinating planet? Proxima b is slightly larger than Earth, placing it in the category of super-Earths. However, its proximity to Proxima Centauri means it experiences a phenomenon called tidal locking, which means one side of the planet is always facing its star. This could create an extreme environment with one side hot and the other cold. The question that arises is, how will this affect the possibility of life on its surface? The other 2 planets in the system, Proxima c and Proxima d, also present intriguing characteristics. Although Proxima c is farther from the habitable zone, studying it could offer clues about the formation and evolution of planetary systems around red dwarfs. Imagine that each of these planets is like a book in a cosmic library, waiting to be opened and explored by scientists. Exploring Proxima Centauri and its planets is a crucial step in our search for life in the universe. Each discovery brings us a little closer to answering fundamental questions about our existence. If we ever manage to visit these worlds, we might find echoes of life or perhaps evidence of advanced civilizations. How would that impact our understanding of the cosmos? However, distance remains a significant obstacle. With current technology, a journey to Proxima Centauri would take thousands of years, but science is advancing rapidly. Projects like Breakthrough Starshot are developing ideas to send small probes at speeds close to the speed of light. This could allow us to receive images and information from Proxima Centauri in a few decades. Can you imagine receiving a signal from a world that could be home to life? As we continue to observe and study, Proxima Centauri becomes a symbol of hope and curiosity. Every time we look to the stars, we are reminded that we are in a corner of the universe filled with mysteries. The search for life beyond Earth is not just a scientific endeavor, it is an exploration of our own humanity and our place in the cosmos. As our tools and methods improve, the possibility of discovering that we are not alone in the universe becomes increasingly real. Proxima Centauri, with its wealth of planets and its proximity, is just the beginning of a fascinating journey. What secrets does the universe still hold for us? The exploration continues, and each new finding opens the door to more questions, inviting us to dream of what might lie beyond our reach. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. Red dwarfs are fascinating stars that play a fundamental role in our understanding of the universe, but what makes them so special? For starters, they are the most abundant stars in our galaxy, the Milky Way. It is estimated that they represent about 75% of all stars. This means that if we look up at the sky, many of those tiny lights we see are likely red dwarfs, even though they are too dim to be seen with the naked eye. Imagine a small campfire in the middle of a vast desert. That campfire is warm and inviting, but it doesn't shine as brightly as a large fire. This is what red dwarfs are like. They are cooler and smaller stars than our sun, but their light and heat can be crucial for the planetary systems that orbit around them. Despite their size, their longevity is astonishing. They are estimated to live billions, even trillions of years, giving them plenty of time to develop planetary systems and potentially life. The temperature of a red dwarf is much lower than that of larger stars. While the Sun has a surface temperature of about 6,000 degrees Celsius, red dwarfs can range from 2,000 to 4,000 degrees. This means that although they are less bright, they can host planets that lie in the habitable zone, where conditions might allow for the existence of liquid water. But what exactly is this habitable zone? The habitable zone is like the ideal place to live in a neighborhood. It's not too hot or too cold, just right in the middle, where life could thrive. For a red dwarf, this zone can be much closer to the star than for our Sun. This raises an intriguing question. Could the planets that orbit these smaller stars harbor life? However, there are challenges. Red dwarfs are known to be very active, especially in their early stages of life. This means they can emit stellar flares and intense radiation that could affect nearby planets. Imagine living next to an active volcano. While it may seem exciting, the reality can be dangerous. This leads us to think about how life might adapt to these extreme conditions, if it exists at all. Most red dwarfs are also much older than Sun-like stars, giving them a very different life cycle. This longevity could be an advantage for any form of life that is trying to develop. In a way, it's as if they have extra time to evolve. But what about the planets orbiting these stars? Have they had enough time to develop features that could support life? In recent years, astronomers have discovered many exoplanets orbiting red dwarfs. Some of these planets, like Proxima Centauri b, are in the habitable zone of their star. This leads us to wonder, what kind of climate might they have? Would they be similar to Earth? The answer may be more complex than it seems. The atmosphere of these planets could be very different due to their proximity to their star. This could influence temperature, pressure, and of course the possibility of liquid water. Some scientists suggest that even if these planets are very different from Earth, it doesn't mean they can't harbor life. Life is incredibly adaptable and can find ways to survive in extreme conditions. But what kind of life forms might we expect? Would they be organisms similar to those we know on our own planet? Red dwarfs, in their essence, challenge us to rethink our ideas about habitability and life on other worlds. They invite us to explore the unknown, to look beyond what we consider familiar. Each new discovery about these stars brings us one step closer to answering one of humanity's oldest questions: are we alone in the universe? In summary, red dwarfs are not only the most common stars in our galaxy, but also the most intriguing. They offer us a fascinating field of study filled with possibilities. The more we learn about them and the planets that orbit around them, the more we realize that the cosmos is full of surprises. Exploring these stellar systems could reveal secrets about our own existence and the place we occupy in the universe. So as we continue our quest to understand these distant worlds, let us remember that each star, no matter how small, has its own story to tell. And perhaps, just perhaps, in one of those red dwarfs, there is a small corner of the universe where life flourishes, waiting to be discovered. The planetary system of Proxima Centauri is a fascinating place that awakens the curiosity of astronomers and dreamers alike. This system, which revolves around the star closest to our Sun, is a small corner of the universe that could hold surprising secrets. But what makes it so special? Let's find out. First, let's talk about the 3 planets that orbit Proxima Centauri. Imagine a cosmic dance in which these planets revolve around their star, each with its own rhythm and unique characteristics. The first in this dance is Proxima Centauri b, an exoplanet located in the habitable zone of its star. This means it could have the right conditions to host liquid water, an essential ingredient for life as we know it. Isn't it amazing to think that there could be water on another world? Now let's consider Proxima Centauri c, a planet that sits a bit farther from its star. It is believed to be a giant ice world covered in ice and cold, where temperatures are extremely low. Can you imagine what it would be like to walk on such a frozen planet? Although life may not be possible there, its existence shows us the diversity of celestial bodies that can inhabit the same system. The third planet, known as Proxima Centauri d, is a bit smaller and less understood than its siblings. With a size roughly similar to that of Mars, scientists are still investigating its characteristics. Could this little world be home to unknown forms of life? The possibilities are endless, and each discovery leads us to new questions. The planetary system of Proxima Centauri is a reminder that we are not alone in the vast cosmos. Each of these planets has its own story and mysteries, waiting to be uncovered by space explorers and curious scientists. But how do we know these planets exist and what makes them so intriguing? The answer takes us to the technology we use to study the universe. Telescopes and other advanced tools have allowed astronomers to detect the subtle movements of stars and the planets that orbit them. Thanks to this, we can infer the presence of these distant worlds. Even though they are over 4 light-years away, it's like trying to see a lighthouse in the fog. Sometimes you only perceive its glow, but you know it's there. Each new discovery in Proxima Centauri offers us an opportunity to reflect on our place in the universe. What does it mean that there are planets so close to us? The possibility of life on them, although still unconfirmed, invites us to think about what might be happening on those distant worlds. Could they be a refuge for intelligent beings? Or perhaps a home for forms of life we have never imagined? Moreover, the existence of these planets raises questions about how planetary systems form and evolve. Proxima Centauri, being a red dwarf, has characteristics that set it apart from other brighter stars. These stars are common in the Milky Way, suggesting that there may be many more similar systems waiting to be discovered. Each star could be home to a new planetary system, full of potential and mystery. With advancements in technology, scientists continue to explore and study these worlds. Imagine in the near future a space telescope capable of capturing detailed images of Proxima Centauri b. What revelations could arise from such close observation? Perhaps we will discover atmospheres, oceans, or even signs of life. Each new advance brings us one step closer to answering questions that have been on humanity's mind for centuries. On the other hand, the exploration of these planets not only offers us the possibility of finding life, but also teaches us about our own Earth. By studying other worlds, we can better understand our climate, our geology, and the processes that have shaped our planet. Isn't it fascinating how looking into space can teach us so much about ourselves? The search for life in the Proxima Centauri system is one of the many adventures awaiting us in the vast ocean of the cosmos. Each discovery is another piece of the universal puzzle, and each unanswered question drives us to want to know more. So as we continue to explore, let's remember that the cosmos is full of wonders, and that perhaps one day we will discover we are not as alone as we thought. In conclusion, the planetary system of Proxima Centauri is a place full of mysteries that invite us to dream and explore. From its 3 planets to the possibilities of life, the study of this system reminds us that the universe is full of surprises. What else will space reveal to us in the future? Only time and our curiosity will tell. The Alpha Centauri star system is a fascinating place that has captured the imagination of astronomers and dreamers alike. What makes it so special? For starters, it is the closest star system to our own Sun. This stellar group is made up of three components: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. So what lies behind these stars that gaze at us from so far away? Alpha Centauri A and B are actually a pair of stars that orbit each other. Imagine two dancers in an elegant waltz, spinning and moving in perfect harmony. Alpha Centauri A is brighter and larger than our Sun, while Alpha Centauri B is slightly smaller and less luminous. Together, they form a stellar duo that has fascinated scientists and the public for generations. Curiosity leads us to wonder, what is the difference between these two stars? Although they are similar, Alpha Centauri A shines with a golden light, while Alpha Centauri B emits a dimmer, yellowish glow. This difference in brightness is not just visual, it also has implications for the planets that might orbit around them. Can you imagine a world where daylight comes from two suns instead of one? Continuing with our journey, we cannot forget Proxima Centauri, the third star in the system. Unlike Alpha Centauri A and B, Proxima Centauri is a red dwarf, much smaller and cooler. Think of it as the younger sibling who always stays home while the other two go out to explore. Although it is less bright, Proxima Centauri has the honor of being the closest star to Earth, just 4 light-years away. How close is that? To put it in perspective, if we could travel at the speed of light, we would arrive in the blink of an eye, but with current technology, it would take us thousands of years. Now let's talk about the planets that orbit these stars. We often wonder, could there be life on those distant worlds? In the case of Proxima Centauri, an exoplanet called Proxima b has been discovered, which is in the habitable zone of its star. This means that it might have liquid water, an essential ingredient for life as we know it. Imagining a planet with oceans, skies, and mountains all under the light of a red dwarf is an exciting thought that sparks our curiosity. But what about the planets orbiting Alpha Centauri A and B? So far, no confirmed exoplanets have been found in their orbits. However, scientists are using advanced telescopes to search for signals of hidden worlds. Each new discovery could be a window into a future where humanity not only explores but also inhabits other star systems. The possibilities do not stop there. Imagine if we discovered a planet that not only has water but also has an atmosphere rich in oxygen. What would it be like to live in a world where the sky is a different color and the stars shine with an intensity unknown to us? The idea of encountering completely different forms of life is something that has always fascinated scientists. Meanwhile, the Alpha Centauri system remains a place of constant study. Each advance in technology brings us closer to uncovering the secrets it holds. Questions continue to arise. Are there more planets out there? Could these worlds harbor life? The search for answers goes on, and each discovery could be a spark that ignites the imagination of future generations. The importance of Alpha Centauri lies not only in its proximity, but also in the fact that it could be the first destination for humanity in the search for new homes in the cosmos. The idea of traveling to another star system may seem like science fiction, but advances in space exploration and propulsion technology bring us one step closer to this dream. Exploring the Alpha Centauri system is not just a matter of scientific curiosity, it is also a reflection of our search for connection. The idea that we might not be alone in the universe is profoundly moving. Isn't it fascinating to think that perhaps one day we could leave a legacy on another world, just as we have done here on Earth? So as we continue to explore our own solar system and beyond, the Alpha Centauri system stands as a beacon of hope and curiosity. Each star, each planet, represents a story waiting to be told. The starry night reminds us that the universe is vast and mysterious, and that our journey is just beginning. What makes a star special? In the case of Alpha Centauri, the answer is an intriguing game of two. This star system, located just 4 light-years from our home, is not a solitary star, but a pair of celestial bodies that dance in a cosmic ballet. Imagine two friends spinning around a point in the middle, each shining with their own light but always connected by gravity. Alpha Centauri A and Alpha Centauri B are those friends. and together they form a system that awakens our curiosity about the universe. Alpha Centauri A is the brightest star of this duo. Its light is comparable to that of the Sun, making it a beacon in the vast ocean of space. Did you know that its mass is 30% greater than that of our Sun? This means that if Alpha Centauri A were a character in a strength contest, it would probably be the champion. But what about its companion? Alpha Centauri B, although a bit smaller, also has its own special shine. Its mass is 20% less than that of the Sun, but don't underestimate it. It's like the best friend who, although not the biggest, always has a unique spark that makes it stand out. The distance between Alpha Centauri A and B is fascinating. Imagine they are separated by a space similar to that between the Earth and the Sun, but in a cosmic context, this is a surprising proximity. Have you ever wondered what it would be like to live in a system where two stars shine in the sky? The answer could be different depending on which of the stars you were orbiting. If you were a planet in Alpha Centauri A, you would have a warm, bright sun, while a planet in Alpha Centauri B might experience a dimmer, more mysterious sky. The light you receive can affect everything from the climate to the possibility of life. Speaking of life, it's impossible not to wonder if there are planets in this system that could harbor it. So far, astronomers have found exoplanets in systems similar to Alpha Centauri, but the discovery of a planet in this system has eluded scientists until now. Nevertheless, studying Alpha Centauri A and B is crucial because what we learn here could reflect other star systems in our galaxy. What conditions would make these worlds a habitable place? The answer to this question could change our understanding of life in the cosmos. The search for planets in the Alpha Centauri system is like a treasure hunt. Scientists use advanced telescopes and sophisticated techniques to detect small movements in the stars that could indicate the presence of a planet. Think of it as searching for a hidden object in a dark room. Every little movement or flash of light could be a clue leading you to that hidden treasure. Although we have not found confirmed planets in this system, the possibility remains exciting. The brightness of Alpha Centauri A and B also plays an important role in this story. The light they emit not only illuminates their surroundings, but also determines the type of planets that could form around them. Brighter stars tend to heat their systems more, while dimmer ones offer a cooler environment. What would happen then if a planet were right in the habitable zone, where the temperature is perfect for liquid water? The answer to this question could be at the heart of the search for life on other worlds. Alpha Centauri A and B are not only interesting because of their proximity and characteristics, but they also play a role in the grand scheme of the Milky Way. This system is like a stellar neighborhood, where each star has its own story. The interactions between these stars, as well as their movement through the galaxy, can influence the formation of new planetary systems. Imagine each star as a point on a cosmic canvas, and their movements create patterns that could lead to new opportunities for life. The radiation emitted by Alpha Centauri A and B also has an effect on the space around them. Interstellar matter can be influenced by their magnetic fields, creating a dynamic environment that could affect the formation of new celestial bodies. This means that we are not only looking back in time when we observe these stars, we are seeing how the present of Alpha Centauri could impact the future of the cosmos. As for the search for life, there is a fascinating aspect to consider. The distance to Alpha Centauri is so close that humanity has begun to think about missions to this system. Can you imagine a spacecraft heading towards Alpha Centauri? The idea of visiting another star system is both exciting and terrifying. Exploring these worlds could change our perspective on what it means to be human and our connection to the universe. In the end, Alpha Centauri A and B are more than just two bright stars in the sky. They are a symbol of our curiosity and desire to explore the unknown. Each discovery in this system brings us a little closer to answering the questions that have fascinated humanity for centuries. Are we alone in the vast universe? Could there be other habitable worlds waiting to be discovered? The answer might be closer than we think, at the heart of Alpha Centauri. So, as we look up at the sky, Let's remember that each star has a story to tell, and Alpha Centauri A and B are just the beginning of a cosmic narrative that we still have to explore. The search for answers continues, and each discovery brings us one step closer to unraveling the secrets of the universe. Have you ever stopped to think about the possibilities of life beyond our planet? The search for extraterrestrial life has been a human longing since time immemorial. With the advancement of science and technology, we find ourselves at a point where we can glimpse the possibilities of finding life on other worlds, especially in nearby star systems like Alpha Centauri. But what makes a planet a viable candidate for hosting life? The key lies in a very popular term in astrobiology: the habitable zone. This zone, sometimes known as the Goldilocks zone, is the region around a star where conditions are suitable for water to exist in liquid form. But why water? Imagine that water is like the secret ingredient of life. Without it, the biological processes we know simply wouldn't work. In the Alpha Centauri system, several exoplanets have been discovered that could be in this zone. Sounds exciting, right? Now let's talk about the most intriguing exoplanet, Proxima b. This planet has captured the imagination of scientists and dreamers alike. Why? First, because it orbits Proxima Centauri, the closest star to our Sun. It's like having a neighbor you'd like to invite to a barbecue. But what do we know about Proxima b? According to research, this planet is roughly the same size as Earth and orbits in the habitable zone of its star. However, this is where things get interesting. Its proximity to its star means it faces a challenge. Its star is a red dwarf, which often emits intense radiation. Radiation can be a big problem. Imagine you're outdoors on a sunny day, enjoying the warmth, but suddenly the sun becomes more intense. That could ruin your day. In the case of Proxima b, scientists wonder if this radiation could have affected its atmosphere and therefore its ability to support life. But the questions don't stop there. Could this planet have developed a resilient atmosphere like ours that protects it from harmful radiation? Moving on to another exoplanet in the Alpha Centauri system, we have Proxima c. This planet, although further from the habitable zone than Proxima b, is still an interesting candidate. Imagine Proxima c as the older sibling who has been a bit further away from the fun. Its size is almost twice that of Earth, which could mean it has different gravity. Could this affect how life develops if it exists there? The possibilities are endless and quite exciting. And then there's the enigmatic Proxima d. Although research is still being conducted to better understand this planet, its existence raises fascinating questions. Could it be a small gem in the vast darkness of space? Its size is smaller than Proxima b, suggesting it might have completely different characteristics. Differences in size and composition could influence its environment and the possibility of hosting life. Of course, we cannot forget the influence of the star it orbits. Proxima Centauri, as we mentioned, is a red dwarf and has a much longer lifespan than the Sun. This could allow the planets in its orbit a prolonged time to develop life. It's like having a teacher in school who gives you more time to complete your assignments. Could this favor the development of living beings on these worlds? However, the fact that these planets are in the habitable zone does not guarantee that they are habitable. The reality is that exoplanets are a mysterious world full of surprises. Scientists are still investigating their atmospheric composition, temperature, and other crucial factors. It's like trying to solve a puzzle with pieces that don't fit perfectly. As we gather more data, the pictures become clearer, but there is still much to discover. The search for life in Alpha Centauri is not only fascinating from a scientific perspective, but it also touches the emotional core of humanity. The possibility of not being alone in the universe is a concept that intrigues and unites us. What would we say or do if we found intelligent life on one of those planets? Would we communicate with them? Or would we simply watch from a distance filled with wonder? As technology advances, future missions will focus on these nearby star systems. More powerful telescopes and innovative techniques will allow us to study these worlds in greater detail. So, while we currently only have questions, the future promises answers. Human curiosity is unstoppable, and our search for life beyond Earth is far from a distant dream. In summary, the possibility of life in the Alpha Centauri star system is a blend of hope, science, and mystery. Each discovery brings us a little closer to understanding our place in the cosmos and the potential to share it with other beings. Space exploration is not just a physical journey, but also a journey towards knowledge, connection, and perhaps understanding what it means to be human in a vast and enigmatic universe. Barnard's star is a small but fascinating corner of the cosmos located just 6 light-years away from our home Earth. But what makes this stellar system so special? For starters, it is the second closest star to the Sun, making it a point of interest for astronomers. Its proximity offers us a unique opportunity to study its nature and better understand the structure of our galaxy. As we delve into this system, we discover that it is not just a solitary star, but a place full of mysteries waiting to be unveiled. Barnard's star is a red dwarf, a type of star that is much smaller and less bright than our Sun. Imagine a dim light barely illuminating the surroundings. That is how Barnard appears. However, this small star has a very interesting motion of its own. It moves through space rapidly and notably, making it one of the fastest stars in our galactic neighborhood. It's as if it is in a constant race through the universe. This movement has been the subject of study for decades as scientists have tried to trace its trajectory and understand its history. But what about its planets? For a long time, Barnard's star was an intriguing candidate in the search for exoplanets. The most intriguing question is, are there worlds orbiting around this star? In 2019, astronomers announced an exciting discovery: the exoplanet Barnard B. This planet is unlike those we know, as it is located in a zone that could be hostile to life as we know it. However, its existence raises fascinating questions about the variety of worlds that could exist in our universe. Barnard B is a super-Earth-type planet. This means it is larger than our planet, but not as large as a gas giant like Jupiter, although it is very close to its star, which might suggest an extremely warm climate. The exact nature of its atmosphere remains a mystery. Could there be conditions that allow for some form of life? The temperatures on its surface are unknown, but scientists continue to investigate and model possible scenarios. Barnard's star has a characteristic that attracts the attention of astronomers: its low luminosity. This means that its light is much dimmer compared to other stars, and that affects how we perceive its planetary system. Imagine trying to see a soft light bulb in a dark room. That is what scientists face when studying this system. But despite this difficulty, its proximity to us offers a direct path for future explorations. The search for life in the Barnard system does not stop at Barnard B. Scientists have begun to explore the possibility that there are other planets perhaps farther from the star, where conditions might be more favorable. What if we found a world similar to Earth? The idea that Barnard may host more than one planet is exciting and opens the door to a multitude of questions. Barnard's star is not only an object of study in itself, but it can also help us understand the history of our own galaxy. Its rapid movement and proximity allow us to observe how it interacts with other stars and how it has moved over time. This gives us clues about the formation of the Milky Way and how our neighboring stars may have influenced us. There are many unknowns to resolve in the Barnard system. How many planets are there really around this star, and how do they compare to those we know? Science is advancing rapidly, and each discovery brings us closer to unveiling the secrets of the universe. The exploration and study of Barnard's star are a crucial piece of the puzzle that is the search for life beyond our solar system. The fascination with Barnard's star opens up a range of possibilities about what life might be like on other worlds. Perhaps in the future, advancements in technology will allow us to observe this system more closely. What types of technologies could assist us in this search? Next-generation telescopes and space missions are designed precisely to answer these questions. Human curiosity about the cosmos is insatiable, and each new discovery is another step toward understanding our place in the universe. Finally, Barnard's star reminds us how vast and diverse the cosmos is. Although it is small and dim, its history and mysteries invite us to keep exploring, to keep asking questions, and to keep dreaming about what lies beyond, what other secrets await in the darkness of space. With each new mission and each new discovery, we get a little closer to answering those questions. The adventure of space exploration is just beginning, and alongside Barnard's star, we have a map to continue our quest for answers. In the vast universe, there is a fascinating place just 6 light-years away from Earth, the Barnard star system. But what makes it so special? It's as if it's right next door to our galactic home, yet at the same time, it's a completely different world. The Barnard star, which gives its name to this system, is a red dwarf. It is often considered one of the closest stars to our solar system, but what does that really mean? Imagine the universe as a huge neighborhood, and Barnard is on the closest corner to our house. Unlike our sun, which shines brightly in the sky, the Barnard star is smaller and cooler. In fact, it is so dim that you cannot see it with the naked eye. If we observe the Barnard star with a telescope, what we find is a sphere of gas very different from the one that provides us with light and warmth. But what about its exoplanet, Barnard B? This is a world that has captured the attention of astronomers and dreamers alike. Barnard B is an exoplanet that orbits this star, and its discovery has been a milestone in our search for other worlds. Imagine a planet that is almost 6 light-years away from us, a place where conditions could be very different from what we know. Barnard B is a planet the size of Earth, which means it could have features resembling those of our home. But is it really a place where life could exist? The answer to this question is somewhat complex. Although Barnard B is in the habitable zone of its star, which is the area where conditions might allow for the existence of liquid water, we must consider several factors. The Barnard star is a red dwarf, meaning it emits less light and heat than our sun. This could make any planet in its orbit a cold and dark place. However, the proximity to the star could allow Barnard B to have a warmer climate, similar to what we find on planets closer to the Sun. An intriguing aspect of Barnard B is its rotation. This planet may be in what we call synchronous rotation, meaning it always shows the same face to its star, just as our moon always shows the same face to Earth. This creates one side of the planet that is constantly illuminated and another that remains in perpetual darkness. Imagine a world where one half is bathed in light while the other is plunged into eternal night. How would this affect life if it exists? Scientists are also studying the atmosphere of Barnard B. What gases compose it? Could there be water? These questions are fundamental to understanding the planet's capacity to host life. Meanwhile, the search for life on other planets confronts us with the big question: are we alone in the universe? The exploration of Barnard B could offer us valuable clues about how planets form and whether life can arise under conditions different from those we know. As we advance in our understanding of the cosmos, Barnard B becomes a point of interest not only for its proximity but also for the opportunities it provides to learn about planet formation and the possibility of life beyond Earth. It's as if we have a galactic neighbor inviting us to discover its secrets. Astronomers are constantly seeking new technologies and methods to study exoplanets like Barnard B with advanced telescopes. We can analyze the light passing through the planet's atmosphere, searching for signatures that indicate the presence of water or even life. Isn't it exciting to think about what we might discover in the near future? Meanwhile, the scientific community continues to ask questions about how the next steps in the exploration of Barnard B will unfold. Human curiosity is insatiable, and each new discovery leads us to ask more about our place in the universe. Imagine for a moment that in the not-so-distant future we managed to send probes to this exoplanet. The idea that we could see landscapes, mountains, and perhaps even oceans on such a distant world is truly astonishing. The Barnard system not only reminds us of the vastness of the universe, but also gives us a new perspective on life on Earth. Sometimes looking up at the stars can make us appreciate our own planet even more. The search for life on Barnard B teaches us that curiosity and the desire to explore are part of what makes us human. In conclusion, the Barnard star system and its exoplanet Barnard B are a window into the future of space exploration. As we continue to look up at the sky, each star and each planet tells us stories about creation and life that we are still trying to understand. The next time you look at the stars, think of Barnard B and all the wonders that still await us to discover in this vast and mysterious universe. Lumen 16 is a binary system of brown dwarfs that has captured the attention of astronomers and space enthusiasts alike. What makes this system so special? For starters, it is located just 6 light-years from Earth, making it one of our closest galactic neighbors. But what exactly are brown dwarfs? They are often described as failed stars. While stars like our Sun shine through nuclear fusion, brown dwarfs do not reach the necessary mass to initiate this process. In a way, they are like a fire that never quite ignites but still has the potential to warm its surroundings. Imagine a place where the light is dim and the temperature is colder than a winter day on Earth. That is Lumen 16. This system consists of 2 celestial objects that orbit each other but are not massive enough to be considered stars in the traditional sense. Instead, they emit a faint light, almost like a dying ember. This raises an intriguing question. Could there be planets around these brown dwarfs? As science advances, we have learned that some of these systems may host planets. The idea that a world could orbit a brown dwarf is fascinating. It would be like finding an oasis in a frozen desert. Although the available light is scarce, life as we know it could adapt to very different conditions than those we find on our planet. But what kind of planets could exist here? Astronomers have begun to investigate further. There are indications that there could be planets in the Lumen 16 system, leading us to wonder, what would they be like compared to the worlds we know? These planets might have much colder climates and different atmospheres. However, they could also have unique features such as dimly lit landscapes and unusual colored skies. Imagine walking on terrain where sunlight never shines directly. Yet the environment still feels alive in a completely new way. One of the most intriguing questions about Lumen 16 is its composition. These brown dwarfs have an atmosphere rich in methane, giving them an unusual and mysterious appearance. This atmosphere could influence the possibility of planets existing in their vicinity. But how would these worlds behave in the shadow of a brown dwarf? They might have their own climatic conditions, which would be very different from those found in our solar system. Additionally, being a binary system, the dynamics between the 2 brown dwarfs are fascinating. They orbit each other at a distance that allows the gravity of both to influence any planet that might exist nearby. This interaction could create unique conditions for planet formation. The question is, could these conditions be favorable for life? Some scientists believe that habitability in a system like Lumen 16 could be possible, but with a significant asterisk. Life could exist in forms very different from what we know, adapting to the lack of direct sunlight. They might inhabit underground environments or dark oceans where energy could come from chemical reactions instead of sunlight. This opens up a whole new world of possibilities about where and how life could exist in the universe. Advancements in telescope technology have allowed researchers to observe and study these distant systems with greater precision. As a result, surprising discoveries have been made about brown dwarfs and their environments. But how would it feel to see a planet orbiting a brown dwarf? Imagine being able to gaze upon a world that has never seen daylight. A place where life might be struggling to adapt in the darkness. With each new finding in Lumen 16, a new series of questions arises. What other systems might be hidden in our galactic neighborhood? How many more surprises does the universe hold for us? As our telescopes become more powerful and our observation techniques more sophisticated, the horizon of exploration expands. It is an exciting time for astronomy. And Lumen 16 is just one chapter in a much larger story. Finally, it is important to remember that although Lumen 16 is a distant and mysterious place, it invites us to reflect on our own place in the cosmos. Each discovery about systems like this brings us a little closer to understanding the vastness of the universe and our own possibilities. So as we look up at the sky on a clear night, perhaps we can ask ourselves, what other secrets is the universe keeping from us? Wolf 359 is a star that, although it does not shine with the intensity of others in the night, holds a special place in the history of astronomy. Did you know that it is one of the closest stars to our solar system? It is located just a little over 7 light-years away. To put this in perspective, if light travels at a speed of approximately 300,000 kilometers per second, that means the light we see from Wolf 359 today began its journey towards us more than 7 years ago. But what makes this star so interesting? What is fascinating about Wolf 359 is that despite its proximity, it is a red dwarf, a type of star that is smaller and less luminous than our Sun. Imagine a star like the Sun, bright and warm like a bonfire in the center of a field. Now think of Wolf 359 as a small night lamp that barely lights up the room. This star has only a quarter of the mass of the Sun, and its brightness is so faint that it is almost impossible to see with the naked eye. However, its closeness makes it an essential object of study for astronomers. One of the most intriguing aspects of red dwarfs, like Wolf 359, is their longevity. These stars can live billions of years, much longer than the Sun. Can you imagine a star that is almost immortal compared to others? This makes them ideal candidates for searching for life in their planetary systems, as they would have plenty of time to develop habitable worlds. So focusing on Wolf 359, did you know that this star has a planetary system? Although no planets have been confirmed, there are indications that there could be one orbiting this star. Scientists have speculated about the existence of a planet in the habitable zone where conditions might be suitable for life. But what does this really mean? The habitable zone is like the magical region around a star where a moon or planet could have liquid water on its surface, similar to how Earth has oceans. Despite being so close, Wolf 359 is not affected by the same light that illuminates our daily lives. Its light, although nearby, is so weak that we would need a telescope to observe it. This is where the curiosity of scientists comes into play, who have dedicated years to studying these stars and their surroundings. The search for planets in systems like that of Wolf 359 is a laborious and meticulous process. Astronomers use techniques like transit, where they observe how the light from a star temporarily decreases when a planet passes in front of it. It's like watching a small shadow pass in front of a lamp. If there were a planet in the Wolf 359 system, we could imagine that its inhabitants, if there are any, would see a world very different from ours. The light they would receive would be a redder color due to the nature of the star. They would have to adapt to very different conditions with cooler temperatures, and life could develop in ways we cannot even conceive. Can you imagine what life would be like on such a planet? The importance of Wolf 359 lies not only in its proximity but also in what it represents for the search for life on other worlds. Every new star we study, every new planet we discover brings us one step closer to answering the fundamental question, are we alone in the universe? The search for exoplanets has revealed that there are thousands in our galaxy. But Wolf 359 is one of the stars that gives us the opportunity to investigate further. As we analyze these stars and their possible planets, we also learn more about the formation of stellar systems. How do they form? What conditions are necessary for a planet to become a habitable place? Each discovery in systems like that of Wolf 359 helps us better understand our own place in the cosmos. Reflecting on the importance of Wolf 359, one wonders, what secrets remain to be discovered in the vast space that surrounds us? Stars are like open books, but often we only manage to read the first lines. Each star has its own story to tell, and Wolf 359 is an intriguing chapter in the narrative of the universe. Finally, when thinking about this distant star, it is easy to get lost in the wonder of the unknown. Space exploration has taught us that the cosmos is a place full of surprises and mysteries. With each new mission and each new telescope, we are one step closer to unraveling the secrets of the stars closest to us. like Wolf 359. Can you imagine what discoveries await us in the future? In a corner of the vast universe, among the stars that surround us, there is a system that has captured the attention of astronomers and astronomy enthusiasts alike. It is Gliese 411, a red dwarf that, although small and modest compared to our Sun, offers us countless mysteries and intriguing questions. What makes this star so fascinating, and what secrets does its planetary system hold? To understand the importance of Gliese 411, we first need to know a bit more about these red dwarfs. Did you know that they represent approximately 75% of all the stars in our galaxy? They are like ants in the stellar world, small, abundant, and often overlooked. Although they do not shine with the intensity of larger stars, their long life and stability make them ideal candidates in the search for extraterrestrial life. Gliese 411 is located just 17 light-years away from Earth, which in cosmic terms is practically just around the corner. Imagine you could take a train and travel that distance. It would be like a stroll through the cosmic neighborhood. But what is so interesting about this red dwarf that brings us so close to other worlds? The Gliese 411 system hosts at least one planet in its orbit, known as Gliese 411b. This exoplanet has caught the attention of scientists because it lies in the habitable zone of its star. The habitable zone is like a neighborhood where conditions might be suitable for the existence of liquid water, an essential element for life as we know it. But could we really find water on Gliese 411b? The answer is not so simple. Although the planet orbits in the habitable zone, its proximity to a red dwarf means it is exposed to radiation levels different from those we experience on Earth. This raises questions about its atmosphere. Will it have an atmosphere capable of protecting life? Or will it be an inhospitable place, similar to a scorching desert? Research continues, and each discovery brings us closer to understanding whether this world could be a home for some form of life. But curiosity does not stop there. Gliese 411b is a super-Earth-type exoplanet, meaning it is larger than our planet but not quite a giant. Imagine a basketball compared to a soccer ball. This size gives it fascinating characteristics. Could it have enormous mountains, deep oceans, or even continents like ours? The possibilities are endless, and each new theory opens the door to more questions. Learning more about Gliese 411b also leads us to explore how planetary systems form and evolve. The relationship between the star and its planet is like a cosmic dance, where each has its own rhythm and movement. What forces influence this dance? Gravitational interactions, chemical composition, and the star's history play a crucial role in the stability of the system. As observational technologies develop, scientists are getting closer to answering some of these questions with advanced telescopes. Like the James Webb Space Telescope, we can observe the atmospheres of exoplanets and search for signals that indicate the presence of life. What kind of signals are we looking for? Elements like oxygen and methane are key indicators, and their presence could be a sign of biological activity. However, the study of Gliese 411 and its planet also reminds us of how small our Earth is in the vast universe. Each discovery about this red dwarf invites us to reflect on our place in the cosmos. Are we really alone? Or are there other beings on distant worlds wondering the same about us? These philosophical questions are as important as the scientific ones and invite us to look at the sky in awe. Ultimately, the exploration of Gliese 411 and its system shows us that the universe is full of surprises and mysteries waiting to be discovered. Every star, every planet, every corner of space has a story to tell. And as we continue to seek answers, human curiosity remains the driving force that propels us to explore the unknown. So the next time you look at the night sky and see a bright point, remember that behind that light lies a world of possibilities. Gliese 411 is just one of the many systems waiting for us, filled with enigmas that could change our understanding of the universe. The search for life beyond our planet is a journey that is just beginning, and every small step we take brings us closer to answering one of humanity's oldest questions. What secrets does the cosmos hold? Only time and science will tell. In the vast and intriguing universe, there is a place that shines with a particular intensity, the brightest star in the night sky, Sirius. Also known as the dog star, Sirius has fascinated humanity for millennia. But what makes this star so special? And what secrets does it hide in its bright light? To begin with, Sirius is not alone. It is part of a binary star system, which means it has a companion that orbits it. Together, these two stars form a cosmic duo that has intrigued astronomers and stargazers alike. Sirius A, the brightest and best known, is a white main sequence star, while its companion, Sirius B, is a white dwarf, a stellar remnant that has exhausted its nuclear fuel. Imagine an eternal dance between these two stars, where one shines brightly while the other, dimmer, hides its light in the shadow of its companion. Now, how does Sirius's luminosity compare to other stars? To put it in perspective, Sirius is about 20 times brighter than our Sun. If the Sun were a lit candle in a room, Sirius would be a dazzling lighthouse on the coast. But what about its distance? Sirius is located just 8 light-years from Earth, which means its light takes only 8 years to reach us. This makes it the closest and brightest star we can observe in the sky. A true beacon in the darkness of space. The history of Sirius is as ancient as civilization itself. The Egyptians revered it, associating it with the goddess Isis, and its appearance in the sky marked the beginning of the Nile floods. A crucial event for agriculture. In other cultures, such as the Greek, it was linked to the heat of summer, even being blamed for the heat waves that plagued the lands. Can you imagine that a star could influence the climate of Earth and the agricultural cycles of ancient civilizations? It is astonishing to think about the connection we have had with the stars throughout history. But what about its composition? Sirius A is primarily composed of hydrogen and helium like most stars, but its surface temperature is significantly higher than that of the Sun, reaching around 10,000 degrees Celsius. This not only makes it shine intensely, but also gives it a bluish-white color that distinguishes it in the sky. It's as if it wears a warm coat that makes it glow brighter than other stars. As for its companion, Sirius B, it is fascinating in a different sense. A white dwarf is the collapsed core of a star that has exhausted its nuclear fuel. Imagine that, at the end of its life, a star becomes a kind of shell of what it once was. Sirius B is much smaller and less luminous than Sirius A, but its existence gives us clues about stellar evolution. It shows us how stars live, die, and in some cases leave behind a legacy in the form of new stars or planets. Astronomers have studied the Sirius system for centuries, and thanks to this, we have learned much about star formation and their life cycle. The distance between Sirius A and Sirius B is a reminder that even in the cosmos, companionship is essential. These two stars orbit each other in a cosmic dance that lasts about 50 years, a journey that reminds us that time in space is different from what we know here on Earth. In the search for exoplanets, scientists have turned their gaze to the Sirius system. Although no planets have been found orbiting Sirius A or B so far, the possibility of worlds existing in those surroundings is an exciting idea. Could there be a planet that, although light years away, harbors life? The possibility that another civilization might be observing Sirius is simply fascinating. As we move away from our own solar system and look toward the stars, we find that Sirius is not just a bright point in the sky, but a reminder of our own quest for answers. What lies beyond? Are we alone in the universe? Each star, including Sirius, is a beacon guiding us in our endless search for knowledge. If you look up at the sky on a clear night and see Sirius shining, remember that you are not just observing a star, you are looking at a world of stories, mythologies, science, and mysteries. The light you see has traveled thousands of years, and each twinkle is an echo of the past, a reminder of how small we are compared to the vastness of the cosmos. The next time you find yourself under a starry sky, take a moment to contemplate Sirius. Ask yourself what secrets it has witnessed over the years. The story of this star is just a part of the vast puzzle of the universe, and every answer we find only leads us to more questions. Who knows what discoveries await to be revealed in the coming decades? The exploration of space is far from over, and Sirius, with its brilliant light, will continue to be a beacon illuminating our path. In the vast ocean of space, there is a star system that shines with a special light. We are talking about the Alpha Centauri system, a fascinating place full of mysteries that invites us to delve into its secrets. But what makes this system so intriguing? To understand it, we must explore what it consists of and how it relates to our own sun. Alpha Centauri is a system located approximately 4 light-years from Earth. A whisper in astronomical terms. Imagine that the Sun and Earth are like two friends sharing coffee on a terrace. In this terrace, Alpha Centauri would be the neighbor who is always nearby, but who, despite its closeness, is often overlooked. This system is not just a star, but a collection of 3 celestial bodies that tell us a fascinating story about the formation of star systems. At the heart of Alpha Centauri, we find 2 companion stars, Alpha Centauri A and Alpha Centauri B. Both are similar in characteristics to the Sun, but with their own peculiarities. Did you know that Alpha Centauri A is a bit larger and brighter than our Sun? However, Alpha Centauri B is smaller and less luminous, like a sibling who prefers to stay in the shadows. This interplay of light and shadow between these 2 stars raises an intriguing question. Could there be habitable worlds orbiting around these stars? Let's imagine that each star is like a sun in its own solar system. What if there were planets revolving around Alpha Centauri A? With its greater luminosity, it could offer favorable conditions for life. But we must also consider Alpha Centauri B, which may influence the climate of the surrounding planets. This dance between stars creates a dynamic environment where gravity and light intertwine in surprising ways. However, the true gem of this system might be Proxima Centauri, the 3rd star that is part of Alpha Centauri. This red dwarf is smaller and cooler than its sisters, but what makes it special is that it is closer to us, only 4 light-years away. Imagine it as the introverted friend of the group who, although not standing out as much, holds secrets that could change our understanding of the universe. Proxima Centauri has been the subject of intense studies, especially in the search for exoplanets. Speaking of exoplanets, have you ever wondered if there are worlds orbiting Proxima Centauri? The answer is yes. In recent years, astronomers have discovered at least 3 planets in this system, and one of them, Proxima b, is located in the habitable zone. But what does this really mean? The habitable zone is the region where conditions could allow for the existence of liquid water, an essential ingredient for life as we know it. So, could Proxima b be a refuge for life forms? Each of these planets has unique characteristics. Some are rocky, while others may be more gaseous. Here arises another question. What kind of environments could they harbour? Fiery deserts or deep seas? Imagination soars when thinking about these possibilities. The exploration of these worlds could reveal whether we are alone in the universe or if there are other beings looking up at the sky, wondering the same. Returning to Alpha Centauri, the relationship between its stars is a reminder of how gravitational forces can influence planet formation. Imagine a cosmic dance where each star has its own choreography, and the planets have to adapt to their movements. This interaction can create conditions that are both favorable and unfavorable for life. It is a constant tug-of-war that shows us how fragile and amazing our place in the cosmos is. In this context, we cannot forget the importance of the search for life in other star systems. Each discovery brings us one step closer to answering fundamental questions. How did our solar system form compared to Alpha Centauri? What lessons can we learn from these neighboring systems to better understand our own home? The search for exoplanets in systems like Alpha Centauri also offers us the opportunity to reflect on our place in the universe. Each star, each planet has a story to tell. What adventures has each of these worlds experienced? What mysteries still remain hidden in the darkness of space? So as we look up at the sky, let us remember that the Alpha Centauri system is not just a group of stars, but a reflection of our curiosity and desire to explore. Every time we lift our gaze, we are connected to a vast and mysterious universe that continues to reveal its secrets. Who knows what discoveries await us in the future? The exploration continues, and each star, each planet, is a new chapter in the story of humanity and its yearning to know. Dwarf galaxies are like small towns orbiting around large cities, in this case the Milky Way. Although they often go unnoticed, their existence is fundamental to understanding the formation and evolution of our universe. These galaxies, smaller than the large spiral galaxies, host billions of stars, but compared to the Milky Way, they seem almost tiny. The question that arises is, why are they so important? The answer lies in their role as building blocks of the cosmos. Just like pieces of a puzzle, dwarf galaxies can provide us with clues about how larger galaxies formed. Many of these small galaxies are believed to be among the first to form in the universe, making them true cosmic fossils. What secrets could they reveal about the early universe? By observing these galaxies, astronomers can study dark matter, that mysterious substance that makes up most of the universe but that we cannot see. Dark matter acts as a framework that holds galaxies together. Dwarf galaxies, being less massive, are more sensitive to the effects of dark matter, which means they can help unveil its nature. Isn't it fascinating to think that these small galaxies may hold keys to understanding one of the greatest mysteries of the universe? The Milky Way has numerous dwarf galaxies accompanying it on its journey through space. Some of them, like the Sagittarius dwarf galaxy and the Aries dwarf galaxy, are so close to us that they are like cosmic neighbors. Imagine having a small community of stars right next door sharing the same neighborhood. These dwarf galaxies not only orbit the Milky Way but can also interact with it, causing surprising phenomena. When these dwarf galaxies approach the Milky Way, they can be drawn in by its gravity. This encounter can result in galaxy mergers, where a small galaxy joins a larger one, leaving a trail of stars and gas in its wake. This process is similar to what happens when two streams of water meet. The smaller one integrates into the larger one, leaving behind a mix of what they once were. Can you imagine what story those stars tell? Having been part of a dwarf galaxy before being absorbed, often dwarf galaxies are rich in old stars, giving us a window into the past. These stars, which formed in the early days of the universe, are like witnesses that have survived countless cosmic events. By studying these stars, scientists can learn about the history of the universe and how galaxies have evolved over time. What tales could those ancient stars tell? However, not all dwarf galaxies are the same. Some are more active and generate new stars, while others are almost completely passive. Galaxies that are forming new stars are like cosmic workshops where matter transforms and gives rise to new stars. On the other hand, those that do not produce new stars seem to be in a state of rest, like an old town that has stopped growing. What factors influence this difference? Astronomers have also discovered that some dwarf galaxies have surprisingly low dark matter content, raising questions about how they formed. This is an intriguing puzzle that challenges our current theories about galaxy formation. How is it possible for some dwarf galaxies to exist with so little dark matter? This mystery opens the door to new ideas and theories about the universe. As we advance in exploring these dwarf galaxies, we find that they are much more than mere objects of study. They are home to a variety of astronomical phenomena, from supernova explosions to the formation of star clusters. Each dwarf galaxy has its own story, and by studying each one, we are unraveling the history of the universe as a whole. The importance of dwarf galaxies extends beyond our own Milky Way. In other galaxies, like the Andromeda Galaxy, we also find similar systems, suggesting that this phenomenon is common throughout the universe. It's as if each large galaxy has its own collection of small companions. How many more dwarf galaxies exist in the vast universe waiting to be discovered? Advancements in telescope and observatory technology have allowed scientists to detect more dwarf galaxies than ever before. This not only provides us with more data, but also helps us build a more complete map of how dwarf galaxies are distributed in the cosmos. As scientists continue their search, each new discovery can change our understanding of the universe. The exploration of dwarf galaxies also raises questions about our own place in the universe. If we are part of a galaxy that hosts multiple dwarf galaxies, what does that mean for the history of our own galaxy? The relationship between the Milky Way and its neighbors is a reminder that the cosmos is in constant change and evolution. Every star, every galaxy has its own role to play in the grand theater of the universe. Finally, dwarf galaxies are a testament to the diversity and complexity of the universe. From the smallest to the largest, each plays a vital role in the cosmic ecosystem. And as we continue to explore and learn more about them, we come a little closer to understanding the mysteries of the universe. What other secrets does the cosmos hold in its vastness? The answer is on the horizon, ready to be discovered. Dwarf galaxies are fascinating, even though they often go unnoticed in the vast cosmos. Behind their modest appearance lie secrets about the formation and evolution of our universe. What exactly is a dwarf galaxy? Essentially, they are groups of stars smaller than normal galaxies, like small bubbles in a sea of stars. These galaxies can contain anywhere from a few million to a few billion stars, making them the small and less bright neighbors in the great cosmic neighborhood. In the vast universe, dwarf galaxies are extremely common. In fact, it is estimated that there are more dwarf galaxies than large galaxies like the Milky Way. Imagine a party full of people where most are acquaintances you barely know. That's what dwarf galaxies are like. Small, but they are everywhere, making the diversity of the universe even more intriguing. One of the most interesting features of dwarf galaxies is their role in the formation of larger galaxies. They act as building blocks, providing matter and energy that, over time, merge to create larger structures. Think of them as puzzle pieces. Although each one is small on its own, together they can form an amazing picture. And what about their composition? Dwarf galaxies tend to have less dark matter than their larger counterparts. Dark matter is that mysterious substance we cannot see but we know exists because it influences the gravity of galaxies. Among the most well-known dwarf galaxies is the Fornax dwarf galaxy, which is relatively close to our own Milky Way. This galaxy, about 60,000 light-years away, is a small treasure trove of ancient stars. Within it, some of the oldest stars in the universe have been found, offering us a window into the past. What stories could these stars tell us if they could speak? Another interesting galaxy is the Carina dwarf galaxy. This galaxy is a hotbed of star formation, meaning new stars are being created within it at this very moment. Imagine a star factory where gas and dust come together to give life to new luminaries in the sky. This process is not only beautiful but also crucial for the evolution of the cosmos. The stars born in dwarf galaxies may eventually become part of larger galaxies like the Milky Way. Dwarf galaxies can also be home to exoplanets. Although this is not often discussed, some astronomers believe that planetary systems could exist in these small galaxies. What kind of worlds might orbit stars in these lesser-known galaxies? Perhaps there are Earth-like planets, hidden in the darkness, waiting to be discovered. The exploration of these dwarf galaxies could open a new door in the search for extraterrestrial life. As we continue to study dwarf galaxies, we also learn about the history of the universe itself. These small galaxies offer clues about how the large-scale structures we see today were formed. By observing them, scientists can look back in time as if they were reading an ancient book that tells the story of our cosmos. What lessons will they teach us about the past, present, and future of the universe? An intriguing aspect is the interaction between dwarf galaxies and larger ones. Often, dwarf galaxies are attracted by the gravity of larger galaxies, like the Milky Way. This attraction can result in mergers that create new galactic structures. Imagine two friends meeting at a party and deciding to dance together. Their union can lead to a dazzling display on the dance floor of the universe. The Milky Way, in fact, has several dwarf galaxies in its neighborhood. The Sagittarius dwarf galaxy is one of them, and as it approaches our galaxy, it is disintegrating, with its stars being absorbed by the Milky Way. This phenomenon offers us a lesson about the ephemeral nature of dwarf galaxies. Although they may seem small and fragile, their influence on the cosmos is significant and lasting. In observing dwarf galaxies, we also encounter questions about the nature of dark matter and dark energy. These galaxies are natural laboratories that help us better understand the forces shaping the universe. What secrets do these galaxies hold about the future of our cosmic existence? Dwarf galaxies, although small, are essential for understanding the structure of the universe. They remind us that despite their size, every component plays a crucial role in the grand tapestry of the cosmos. The next time you look up at the sky and see a star, remember that it could be connected to a dwarf galaxy, and that in its simplicity, there is a rich and complex story waiting to be told. In conclusion, dwarf galaxies are more than just simple groupings of stars. They are fundamental pieces of the cosmic puzzle. They teach us about the history and evolution of the universe and offer us a glimpse into the mysteries yet to be discovered. Each dwarf galaxy is a reminder that despite its size, its impact is vast and undeniable. As we continue to explore the cosmos, we must not forget the importance of these small giants in our quest for knowledge and understanding of the universe we inhabit. In the vast ocean of space, there is a group of galaxies that seem like small islands floating in the immensity of the universe. These are the dwarf galaxies, fascinating structures that, although less known than their larger siblings, play a crucial role in the history and evolution of our cosmos. But what makes them so important? To understand, we must dive into their world. Dwarf galaxies are like small bubbles of stars, gas, and dust that cluster in space. Although they do not have the grandeur of the Milky Way or Andromeda, they possess their own charm and complexity. Imagine a small village in the countryside full of stories and secrets compared to a bustling big city. In this sense, dwarf galaxies are those small villages that, despite their size, have witnessed extraordinary cosmic events. In the local group, which is like a galactic neighborhood, we find several of these dwarf galaxies. Some of the better-known ones are the Sagittarius dwarf galaxy and the Canis Major dwarf galaxy. But why should we pay attention to these small structures? The answer lies in their role in the formation of large galaxies. These dwarf galaxies are often the building blocks that, over millions of years, merge and form larger galaxies. It's as if they are the pieces of a cosmic puzzle, essential for completing the picture. An intriguing aspect of these galaxies is that many of them are rich in dark matter. This is a mysterious component of the universe that we cannot see directly, but it influences the gravity and movement of stars. Can you imagine having a room full of things you cannot see but that are there, affecting everything around you? That's how dark matter works in these galaxies. Although we cannot observe it, we know it is there and plays a fundamental role in how these dwarf galaxies behave. But it's not just about their structure and composition. Dwarf galaxies are also a natural laboratory for studying stellar evolution. By observing how stars are born and die in these small galaxies, astronomers can gain insights into how larger galaxies evolve. It's like studying the growth of a small plant to understand how an entire forest develops. Every star that is born and dies in a dwarf galaxy tells a story about the history of the universe. The Fornax dwarf galaxy, for example, is a place where numerous ancient stars have been found. These stars are like cosmic fossils, offering us a glimpse into the past of the universe. By studying these relics, we can begin to unravel the mysteries of how the first galaxies formed and how they have changed over time. Each star is a small witness to the history of the cosmos. The interactions between dwarf galaxies and larger galaxies are equally fascinating. Often these small galaxies are devoured by larger neighbors. A process that may seem violent, but is also part of a natural cycle. When a dwarf galaxy merges with a larger one, stars and gas are transferred, which can fuel the formation of new stars in the larger galaxy. It's a cosmic dance of creation and destruction where every movement has a purpose. Observing dwarf galaxies has also led to surprising discoveries about dark matter. Astronomers have realized that these small galaxies seem to be surrounded by a halo of dark matter. giving them unexpected stability. This halo is like an invisible shield that protects the galaxy, allowing it to exist in a universe where gravity and other cosmic forces are in constant play. As technology advances, scientists are discovering more dwarf galaxies. Space missions and more powerful telescopes are allowing us to see farther and clearer than ever before. This means we are on the cusp of a new chapter in the exploration of the universe. Each new dwarf galaxy we find is like opening a new book in a cosmic library full of stories yet to be told. Sometimes dwarf galaxies can even reveal secrets about the history of the universe itself, for example, by studying how they are distributed in space and how they interact with each other. Scientists can gain clues about the expansion of the universe and the formation of large-scale structures. It's like trying to reconstruct an ancient map from scattered fragments of information. As we delve into the study of dwarf galaxies, it is important to remember that the universe is a constantly changing place. What we know today may be just the tip of the iceberg. Every discovery can open new questions and mysteries, pushing us to explore beyond the known. Dwarf galaxies, though small, are a window into a larger and more complex universe that we are just beginning to understand. As we conclude our exploration of dwarf galaxies, it is clear that these small worlds have a disproportionate impact on our understanding of the cosmos. They are not just points of light in the sky, but essential pieces of a puzzle that continues to evolve. The next time you look at the stars, consider that behind each twinkle there may be a dwarf galaxy with its own story, waiting to be discovered. Curiosity about the universe should never stop, for there is always more to learn and explore in this vast and wonderful existence. In 1930, an astronomer named Clyde Tombaugh made a discovery that would change our understanding of the solar system. What was it about? A small icy world that would become the 9th known planet of our system, Pluto. But what makes this dwarf planet so fascinating and special? Let's find out. First, let's talk about its location. Pluto is located in what is known as the Kuiper Belt, a region filled with icy and rocky objects that orbit the Sun beyond Neptune. Imagine a gigantic field of snowballs where Pluto is just one of many dancing in the cold of space. But what makes it different from the others? One of the most intriguing features of Pluto is its size. With a diameter that is barely 1/5 that of Earth, you might think of it as a small child in an amusement park, surrounded by giants. Despite its size, Pluto has a thin atmosphere primarily composed of nitrogen, with traces of methane and carbon monoxide. Have you ever wondered how such a small world can have an atmosphere? It's a true mystery of nature. Moreover, Pluto does not orbit the Sun in a straightforward manner. Its orbit is elliptical and somewhat tilted, which means that sometimes it gets closer to the Sun than Neptune. It's as if it's doing a cosmic dance, moving to its own rhythm instead of following the rules. Isn't it surprising to think that Pluto can be closer to the Sun than its larger neighbour at certain times? The surface of Pluto is equally fascinating, with water ice mountains and vast nitrogen plains. Its landscape looks like something out of a science fiction movie. Imagine a world where glaciers are more common than trees. How can that ice survive in such a cold and distant place? Pluto is a place where science and imagination meet. But Pluto's story doesn't end here. In 2015, NASA's New Horizons mission made a historic flyby, sending detailed images and data about this dwarf planet. The photos revealed a world much more complex than previously imagined. Can you imagine the scientists' surprise at seeing mountains and valleys in a place that many thought was just a boring, icy object? One of the most impressive findings was the presence of a large dark spot called Sputnik Planitia, which appears to be a vast sea of ice. This discovery led to the question, could there be some kind of geological activity on Pluto? Is it possible that this small world still has some secrets hidden beneath its surface? And speaking of its moons, we cannot forget Charon, the largest of them. Charon is so large compared to Pluto that, in a sense, both celestial bodies orbit around each other like two dancers on a stage. This duo has a unique relationship, making them a binary system, which means their dance is much more complex and beautiful than we could have imagined. In addition to Charon, Pluto has other smaller moons, such as Hydra and Nix. These moons are like the small satellites of a king, orbiting around it and adding even more mystery to Pluto's story. What secrets could these moons hold? Science is still trying to answer that question. In 2006, Pluto was reclassified as a dwarf planet. This decision caused quite a stir in the scientific community and among astronomy enthusiasts. What does it really mean to be a dwarf planet? Pluto, although smaller, remains a fascinating object that teaches us a lot about the formation of our solar system and the limits of our understanding. The story of Pluto is a mix of discovery, mystery, and controversy. As we continue to explore the cosmos, each new mission and each new discovery brings us a little closer to understanding not only Pluto, but also the nature of the universe we live in. But the question remains, what else is out there waiting to be discovered? With each advance, we delve into a sea of possibilities. So as we look up at the starry sky, let's remember Pluto and all the wonders it offers. This small, icy world teaches us that the cosmos is full of surprises and that there is always something new to learn. Space exploration is just beginning, and who knows what treasures lie beyond our sight. The adventure of discovery continues. The moons of Pluto are like little companions dancing around a dwarf giant. Did you know that Pluto has 5 known moons? Each one has its own personality and fascinating characteristics. Let's dive into this intriguing system. First, let's talk about Charon, Pluto's largest moon. Charon is so large compared to Pluto that some astronomers consider the two bodies to form a binary system. If Pluto were a giant in a dance, Charon would be its partner who, although smaller, has a significant weight in the choreography. Can you imagine what it would be like to see these two celestial bodies spinning together in the vastness of space? Charon has a surface filled with canyons and a landscape that seems to tell a story of collisions and transformations. But what about the other moons? In addition to Charon, Pluto has 4 smaller moons: Nix, Hydra, Kerberos, and Styx. Although they are less known, each one has its own mystery. Have you ever wondered why they have such peculiar names? Myths and legends offer us clues. Nix, for example, is named after the Greek goddess of night. Meanwhile, Hydra, the famous mythological creature, also makes its presence felt in the sky. It's as if the ancient world of myths is connecting our universe with the past. Let's talk about Nix, which is a bit smaller than Charon, but no less interesting. Its surface is reflective, suggesting it may have ice. Imagine a place where the sun's rays shine intensely, illuminating a frozen landscape. Isn't it fascinating to think that in this corner of the solar system, there is a moon that seems almost magical? This brightness could provide clues about Nix's composition and how it formed. On the other hand, Hydra, Nix's sister, is even smaller and has an irregular shape. Did you know that its shape resembles more of a potato than a sphere? This is due to its low gravity, which cannot mold it into a more rounded shape. This curious aspect tells us about its history. Perhaps it formed from the remnants of collisions in space, making it a witness to a tumultuous past. Now, what about Kerberos and Styx? These 2 moons are even smaller and less known. However, that doesn't make their existence any less important. Kerberos, with a name that evokes the mythological creature that guarded the gates of the underworld, is a place where science still has much to discover. Could there be ice on its surface? What secrets does it hold within? Styx, for its part, is the tiniest of them all. Its name comes from the river that separates the world of the living from that of the dead in Greek mythology. This suggests that there is an air of mystery surrounding this little moon. What will it tell us about the origins of Pluto and its lunar family? Each new discovery made about Styx can help us understand how this complicated system formed and what it has experienced over the centuries. The relationship between Pluto and its moons is like a delicate balance. Charon, although the largest, is not just a satellite, it is a companion that influences Pluto's rotation. This phenomenon causes the dwarf planet to spin in a unique way. creating a cosmic dance that lasts one day on Pluto, which is equivalent to 6 days on Earth. This type of interaction shows us how celestial bodies can influence each other, like a game of dominoes where one movement affects all the others. Despite being a dwarf planet, Pluto and its moons offer us a valuable lesson about the diversity of the solar system. Each moon, with its history and characteristics, is a reminder that space is a place full of surprises. Who knows what future discoveries await us? Each space mission, each telescope focused on the sky, could unveil secrets hidden for millennia. Exploring Pluto's moons also helps us better understand the processes of planetary system formation. These moons, like the planets that orbit larger stars, are pieces of a cosmic puzzle. Can you imagine how all these pieces fit into the vast picture of the universe? In conclusion, Pluto and its moons are a window into the past and future of our solar system. As we continue to investigate and learn about these celestial bodies, we are also exploring the history of the formation of our own home. Each moon, each icy surface, and each shadow in space tells us a story waiting to be discovered. So keep your eyes on the sky, because the universe always has more to offer. In this vast universe filled with mysteries and wonders, we have traveled together on a fascinating journey through stars, planets, and systems that challenge our imagination. The exploration of the cosmos is a journey that never ends. And each discovery invites us to reflect on our own existence and our place in the universe. What have we learned along the way? What do those bright points in the night sky really mean? As we have explored nearby stellar systems, we have come to understand that we are not alone in our quest for answers. Proxima Centauri, Alpha Centauri, and so many other stars tell us stories of formation, evolution, and perhaps of life. What if, in a distant corner of the cosmos, there were life forms similar to our own? The possibility is as intriguing as it is astonishing, leading us to wonder, what do we need to find life beyond our planet? Most of the stars in our galaxy are red dwarfs, small and dim, but they are also the most common. In a sense, we might think of them as the small cafes in a city full of grand restaurants. Although they may not be the most dazzling, they have their own charm and are often where the best stories are found. Each star, each planet, is a page in the book of the galaxy, waiting to be read. The Alpha Centauri system, with its 2 main stars, shows us that diversity in the cosmos is the norm. Who could imagine that 2 such different stars could coexist in the same system? The search for exoplanets in these systems reminds us that the universe is a place full of surprises, and that each discovery could bring us closer to answering the oldest question of all: are we alone? When we observe Barnard's star, we realize that sometimes the closest treasures are the least known. Did you know it is one of the closest stars to Earth and yet has gone unnoticed by many? Its exoplanet, Barnard B, offers us a unique opportunity to study conditions that could be similar to those on our own planet. What secrets could that remote world reveal? Lumen 16, a binary system of brown dwarfs, raises questions about the classification of stars and their evolution. It's as if there are classes of stars in the universe, each with its own story and characteristics. What lessons can we learn from these binary systems? They could teach us about the formation of planetary systems and how gravity can shape the fate of distant worlds. Wolf 359, though small and dim, sparks curiosity. What if we found a habitable world orbiting such a faint star? The exploration of Gliese 411 reminds us that even the least bright stars can have fascinating stories to tell. Perhaps there are planets harboring life just waiting to be discovered. The brilliance of Sirius, the brightest star in our sky, makes us reflect on perception. What does it mean to be bright in a universe full of lights? Sirius teaches us about the importance of perspective and how sometimes what seems obvious may just be the tip of the iceberg of something much deeper and more complex. The Alpha Centauri system, which is a reflection of our solar home, invites us to dream. What if in the not-so-distant future we could travel to those systems? The exploration of dwarf galaxies and the Magellanic Clouds shows us that the universe is a woven fabric of stories. Each dwarf galaxy is a fragment of history, a piece of the puzzle that composes our understanding of the cosmos. As we look toward the galaxies of the local group, we realize that we are not alone in our search. The interaction between these galaxies reminds us that the universe is a dynamic and ever-changing place. How do they influence each other? Each collision and merger is a cosmic dance that teaches us about evolution and growth. The story of the discovery of Pluto is a reminder of human curiosity. Sometimes the most significant discoveries come from the relentless search for answers. Pluto, although no longer considered a major planet, remains a fascinating phenomenon. What does its discovery tell us about our own quest for knowledge? The moons of Pluto, worlds in their own right, show us that often the small can have a great impact. Each moon has its own story and unique characteristics. What mysteries could they reveal if we had the chance to explore them up close? The exploration of these celestial bodies could offer us clues about the formation of our solar system. At the end of this journey, it is vital to remember that each discovery, each star, and each planet brings us closer to understanding not only the cosmos, but also ourselves. What does it mean to be part of such a vast and complex universe? Curiosity is the spark that drives us to keep exploring, to keep asking. The exploration of the cosmos is a journey that never ends, and although we conclude this section today, the universe continues to expand and reveal itself before our eyes. Every night when you look at the sky, remember that those points of light are much more than stars. They are worlds full of possibilities, and perhaps one day we will find answers to the questions we can only ask today. The adventure is just beginning.